Well, now that you've survived a bunch of trigonometry, welcome to the wonderful world of circles. At this point, we're really starting to move out of some of traditional plane geometry because that deals with polygons. Circles are not polygons. However, you're going to find very quickly that we start putting circles or polygons inside circles and circles inside polygons, and we're going to relate the two quite a bit. So a lot of stuff going on here, but circles are a little bit of a different beast. First off, before we can talk about circles, we have to talk about the language of circles and the vocabulary associated with them. A radius, a diameter, a chord, a secant, a tangent, a point of tangency, these are all important concepts that you have to really make sure you know. Now, I'm sure most of you know radius and diameter, okay? We've seen these plenty of times. You know, the radius of a circle. I got kind of this here I can highlight a little bit, okay? We've seen that. The radius circle goes from the center to a point on the edge. A diameter of a circle, apologies here for the little bit, but the diameter here goes all the way across the circle and through the center, and a radius is half the length of a diameter, or a diameter is twice the length of a radius. Pretty simple, okay? Those are pretty easy concepts. A chord is a segment that has both endpoints on the circle. Okay? So when it comes to segments, the following things are segments. A radius is a segment. It has two distinct endpoints, one at the center, one on the circle. A diameter is a segment, two distinct endpoints, both on the circle, but passes through the center. And a chord is a segment, two distinct endpoints, both on the circle, but not passing through the center. So technically, a diameter is a type of a chord because it has both endpoints on the circle, but a diameter is special because it passes through the center of the circle. It is the longest chord of the circle. There are two special parts that are also lines. Okay, a tangent is something you are probably familiar with. A tangent line is a line that just touches the circle at a single point. That point where it touches is called the point of tangency. But that's a tangent line. The other one you probably haven't heard of before is a secant line. A secant line contains a chord, but it is a line. It extends beyond the circle. The chord has distinct endpoints on the circle. The secant line goes beyond that and on into infinity. It's a line. And a secant line intersects the circle at 2 points instead of just at 1 point. Tangent intersects at 1 point. A secant intersects at 2 points. And again, we talk about points on the circle. And it's also just kind of important to remember with a circle, just very basically, when I have a circle, let's say that's the center of the circle, C, I can name the circle. I call it by its center point, so I call this circle. I can't spell today. Apparently I can't write R's currently. Try again. Here we go. I'm going to call it circle C by its center point. Sometimes they use a symbol here, a circle with a dot in the center, C, but quite honestly, it looks like a letter O to me, and it's always very confusing, or maybe a single eye staring at me, which is kind of creepy. So I don't use that symbol very often. I just use the word circle C to name it. We use the center point of the circle. Any point with a circle can be one of three places. I'm going to call a point P here, okay? Right now, point P is outside the circle. Now point P is inside the circle. I can also have a point P that is on the circle. If it's on the circle, it means it's on the actual line that's drawn to make the circle. A point P at the center of the circle is in the circle just like any other point P in the circle. So a point can be outside the circle, inside the circle, or on the circle. And technically the way we define the circle is all points equidistant from a given point. So every point on the circle, P, for every P, no matter where P is, the distance from P to C from the center of the circle is a constant. That distance is the radius of the circle. So we understand what a circle is from a geometric definition. Good portion of what we're doing today is just identifying what is it. Okay? Is it a segment, or is it a chord? Is it a diameter, radius, secant? What's going on? So finding and noting what's going on. Segment AC. Okay, segment starts at A and goes to C. What do we call that? Obviously, endpoints are on the circle and at the center. That is a radius. Segment AB. Segment AB, two endpoints on the circle. That could be a chord. Oh, but it goes through the center, making it a diameter. DE, and it looks like, it's a little bit hazy there. It looks like either a ray symbol or a line symbol, but when I draw it here, DE, even if it is a ray, goes right there, and that would be touching the circle at one point, making it a tangent. And AE, gosh, they're being really sneaky here. AE is this line here. And a line passing through the circle at 2 points. If it was just segment AG, that would be a chord, but it's line AE. It goes beyond the circle. That means that that is a secant. So identifying parts. Same picture, what are we going to call AG? That's your first question. Okay? So here it says in example 1, name a tangent and a tangent segment. A tangent, by definition, is normally a line. So the tangent to the circle here, I could name the line, it's this line here. I can pick any 2 points on the line to name the line. So I could call it DB, BE, DE, EB, ED, BD, any of those. I'm going to choose the points that aren't the point of tangency, so I'm going to call it DE. But if you called it BE, line BE, that would be fine. If you called it line ED, that would be fine. A tangent segment, again, same thing. Any of the points would work, but it's asking specifically for a segment this time, so I could say the same name, just as a segment. Those are tangents. All right. Coplanar circles and common tangents. When I have two circles in the same plane, basically one of several things can happen. Here I got two circles. All right? These two circles do not intersect. But, and that's one of the things that can happen. Another thing that can happen is they intersect, but they just intersect externally. They're outside each other, but they intersect at one point. That's called externally tangent circles. Okay? Or they can overlap each other like this, and now they are just intersecting circles, 2 points of intersection. As this continues to move and touches again at a single point, now the circles are tangent again, but that's internally tangent. And finally, we come back to no points of intersection, where the two circles are just one inside the other. And it gets special when they share the same center point, which I'm guessing at here. It looks like a donut. We call that concentric circles. So again, how can two circles interact with each other? They may be completely non-intersecting and external to each other. They might be what we call externally tangent, 1 point of intersection. but the circles are outside of each other. They may be intersecting, where they have 2 points of intersection. They may be internally tangent, back to 1 point of intersection. Or one circle might be completely inside the other circle, no points of intersection. Special case, when it's at the center, it has a special name called concentric. So that kind of sums up what's going on here. Now, one of the things that we're interested in is how many common tangents will there be for these circles? And it kind of depends on how they intersect. In other words, how many lines will be tangent to both circles? It's a little bit tricky to work on, but we can draw it pretty quickly. When the 2 circles are completely external to each other, I can draw, and I'm going to try to make this as good as I can here. It's a little bit tricky. I'm going to be able to draw actually 4 lines such that those lines are tangent to both circles. Oops, this one isn't so good anymore. Make it tangent. There we go. That one's not bad. This one I'm going to try to make it tangent. Okay, good. So I can draw actually when the 2 circles are completely apart from each other, I can draw 4 lines that are common tangents. Okay? They're sometimes referred to external and internal tangents. The external ones are the ones that don't cross between the circles. The internal ones do. So when the 2 circles do not intersect at all, there are 4 common tangents. Guess what? Every time we move the circles closer to each other, we're going to get rid of some of those tangents. The number is going to decrease. We start at 4. But if the circles now are just touching each other externally like this, we still get our 2 common external tangents, which I'm going to have to carefully adjust here. Okay. But now for common internal tangents, I can just squeeze 1 line through here. Okay. That's a little bit dicey, but you get the idea. So now we're down to 3 common tangents when they're externally tangent. As the circles now become intersecting, the internal tangent goes away. And now we're left with just 2 common external tangents. Okay? So now we have 2 tangents. As my small circle now moves even closer and just becomes internally tangent to the circle, guess what? In fact, I'm going to move it so it's internally tangent here, just for fun. Actually, let's be smart. Let's move it internally tangent there. Now we just have 1 common tangent line at the point of tangency. And when one circle is completely inside the other and they don't intersect at all, now we have no common tangents. So finding common tangent lines is one of those things that we like to do if I have more than 1 circle. So just as a review, we just did it. For part A, the 2 circles are completely apart from each other. How many common tangent lines did we have? Well, we had 1, 2, and these are a little tricky to draw, but 3 and 4. So we had 4 common tangent lines. When they're externally tangent like this, we had 1, 2, 3 common tangent lines. How many do we have when they're intersecting? That's our final question of the day and lead us into our work time in class.